with the Pre-Calc Honors Semester 1 review problems 25 to 36, except for the review ended up skipping problem 25. So we're going to start with problem 26. Problem 26 wants you to evaluate on the calculator the sum of n squared plus 1 from n equals 1 to n equals 20. If you did this algebraically or by hand, you would plug in every number from 1 to 20 and then all those outputs you would add together. Well, that's going to take a lot of time and we don't want to do that. So, on your calculator, press the math button, and if right below log base is a function called summation, then you can just call that up and fill in all the blanks, which would be these things. However, if you have an older version of the calculator, you just don't have the newer operating system, in order to do this on your calculator, you would first go to second stat, and then you would go over to math, and then you call up number 5, sum. And then that will pop up on your home screen, and then you go back in again to second stat, but this time you go 1 to the right to ops, and number 5, sequence. So now your calculator says sum sequence, although if you have a newer operating system, you may get a listing of things. If you have an older version of the calculator, this is what you need to type in, and if you have the listing, you need to type in the same stuff. The first thing you do is you type in the equation, x squared plus 1. Second, you need to tell the variable that you're using in your equation, which we're always going to use x, comma, and you should know where the comma button is underneath the sign function. After you put in the variable, the next thing you do is put in the starting value. You want to start by plugging in 1, because that's the bottom number, comma, and then you put your ending number, 20, and then last you put the, what's called a step. You're always going to put a 1. Step just means you're going to type in the consecutive numbers 1, 2, 3, 4, 5. If you were to make this a 2, it would do 1, 3, 5, 7, 9. You don't want to do that. And then you close the parentheses, you hit enter, and then the answer 2890 should pop up. In problem 27, you want to find the sum of the first 8 terms of the sequence 3 minus 6 plus 12 minus 24 plus ... Well, you have to know which sum equation to use. Are you using sum for an arithmetic sequence, or are you using sum for a geometric sequence? Because the formulas are different. Here's a little hint. Anytime you have a series that's alternating signs, it's either geometric or neither. It can't be arithmetic and skip between positive and negative. So, it must be geometric. The common ratio is always the second term divided by the first, or it's the third term divided by the second, or the fourth term divided by the third, but any way you cut it, you'll get -2. The formula written on the review packet is not the formula that I use for finding the sum of a geometric sequence. It's similar to it, though. And the review formula sheet I will give you for the final will have this other way of doing it. The formula that I like to use is a sub 1 r to the n minus 1 over r minus 1. It's the same formula, it's just rewritten a little bit. So you need to know the first term, and you need to know the common ratio, and you need to know how many terms you're adding. So the sum is going to be 3, -2 to the 8th minus 1 over 8 minus 1. So first I would evaluate this in my calculator, and then I'd multiply that answer by 3. Any way you do it, you should get -255. Problem number 28 says, write the equation of a circle whose radius is 9 and the center is at -5, 2. The formula for a circle is x minus h squared plus y minus k squared equals r squared, where h, k is the center. So when you plug in -5 for h, you're going to get x plus 5 squared plus y minus 2 squared is equal to 9 squared, which is 81, and that's the equation. But what if I asked you to graph this? Because on the final exam, you'll have a problem where you're asked, which one is the correct graph. I would first graph negative 5, 2, or I would look for which one has a center of negative 5, 2, and which one has a radius of 9. So negative 5, 2 is here. And then to graph it, I would go 9 units to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the left, 9 units down, and 9 units above, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then there's your circle, not beautifully drawn, but that's what it would look like. Remember, on a multiple choice test, you're not going to be graphing anything. You're going to be identifying which multiple choice answer has the correct graph. So in number 29, it says sketch this ellipse. On the final, it would not tell you that it's an equation of an ellipse, and maybe 2 of the multiple choice answers would be hyperbolas. But on the review, we tell you that it's an ellipse. It's an ellipse whose center is at the origin, because this is really x minus 0 squared and y minus 0 squared, even though we didn't write it that way. Now, here's a cheap trick for quick graphs. The number that's underneath of x is how far you're going to go to the left and right when you square root it. And the square root of 4 is 2, so you would go 2 to the right and 2 to the left. And then when you square root this, because it's underneath of y, that's how far above and below center you're going to put your vertices. Square root of 36 is 6, so 1, 2, 3, 4, 5, 6 above, and 1, 2, 3, 4, 5, 6 below. And then there's my ellipse. The graph, if instead you have a hyperbola, is going to be similarly done, except it's not going to be an ellipse. The center is at 0, 0. And then there's some point 2 units left and right of center, and some point 6 units above and 6 units below center. It's just that these points don't make an ellipse, they make a box, whose diagonals are the asymptotes of my hyperbola. The other thing you have to determine is, how does your hyperbola open? That depends on which variable comes first. Since x comes first, it opens left and right. It means the vertices are on the x-axis. If y had come first, the hyperbolas would have opened up and down. Number 30 asks us to rewrite this equation in graphing form. Well, first you have to know what kind of conic it is. Notice that we have an x squared and a y squared, which means it has to be a circle, ellipse, or hyperbola. Since there's a plus sign, it's got to be a circle or an ellipse. Since the coefficients of x squared and y squared are different, it must be an ellipse. So we're going to divide everything by 100 to rewrite it in graphing form. So it's going to be x squared over 25 plus y squared over 4 equals 1. In number 31, we want to know what the vertex of this parabola is going to be. Well, first of all, I want you to determine what type of parabola it is. Is it a parabola that opens up or down, or does it open left or right? Well, it depends on which variable is squared. Since y is squared, it's going to be one that opens left or right. So if you look at your set of definitions for parabolas, in vertex form, it's going to be y minus k squared is equal to 4p x minus h. That means I want to complete the square on the y's. So y squared minus 8y plus blank. The other two terms are going to get moved to the other side of the equation. So it's going to become positive x and negative 18. And remember, since we're completing the square and adding a new number, you've got to add the same number to the right-hand side. What number goes in the blank? Well, 8 divided by 2 is 4. 4 squared is 16. In factored form, this is going to be y minus 4 squared. And really, this is just a 1 here, but it makes no difference because the vertex, no matter how it's written, is still at h comma k, where this is h and this is k. So h is 2, k is 4, so the vertex must be at 2, 4, and I can tell you that parabola opens to the right. Number 32, solve this compound inequality and write the answer in interval notation. I'm not sure how you learned how to do these problems, if you learned to write it as two separate inequalities and solve each of them, or to leave it in this format and solve. The way that I like to teach it to Algebra 1 students is I tell them I want x to be the only thing left in the middle of the problem. So that means the 2 and the minus 10 have to go away. And you got to use your regular algebra rules for determining which one goes away first. Got to get rid of the minus 10, and you do that by adding 10. It's just, you have to add 10 to all 3 sections. So you get 24 is less than 2x is less than or equal to 38. Now you can get rid of the 2 by dividing, and you get 12 is less than x is less than or equal to 19. In interval notation, this would be parentheses 12, comma 19, bracket. Problem 33 says, write the equation of a line through the point 5, negative 2, and parallel to the equation 2x plus 8y equals negative 10. When two lines are parallel, their slopes are equal. So if my new point is parallel to 2x plus 8y equals negative 10, then I need to find the slope. I'm going to skip steps because this is the honors class. And you put this in slope-intercept form, you should get y is equal to negative 1/4 x minus 5/4. So the slope is negative 1/4, which means the slope of my new line is negative 1/4. And for the purposes of calculus, since I know the slope and a point on a line, I'm going to use point-slope form to create my equation. So it's going to be y plus 2, because I'm plugging in a negative 2, equals negative 1/4 x minus 5. Or if you need to write it in slope-intercept form, you would distribute. And then you would subtract 2. And you would end up with negative 1/4 x minus 3/4. Number 34 says, given that f of x is 5x minus 6 and g of x is 3x squared minus 1, find g of f of x. We're also going to find f of g of x just because. This is called the composition of functions. This is where you plug one equation into the other in place of x. So we're going to plug f into g in place of x, which means I've got 3 parentheses, 5x minus 6 squared minus 1. I would first square 5x minus 6, which is 25x squared minus 60x plus 36. And then I would distribute 3. I would get 75x squared minus 180x plus 108 minus 1. And then I would combine these. So the answer is 75x squared minus 180x plus 107. If I wanted to do f of g of x, that one says plug g into f. Plug this into this equation in place of x. It'd be 5 parentheses 3x squared minus 1 minus 6. I would distribute 15x squared minus 5 minus 6, and then I combine my like terms, and it would be 15x squared minus 11. Number 35 says find the average rate of change of f of x is equal to x squared minus 3x between x equals 4 and x equals 6. Remember, average rate of change is the same thing as slope. So our definition is f of b minus f of a, which is the same thing as y2 minus y1 over b minus a, which is the same as x2 minus x1. So if you call this a and you call this b, f of b, so 6 squared minus 3 times 6 is going to be 18. F of a, which is 4 squared minus 3 times 4, is going to be 4. And then the denominator, 6 minus 4, is 2, so you get 14 over 2, which is 7. Problem number 36. Find the inverse function of f of x is equal to 3x to the 4th plus 2. When you have an equation as opposed to a formula, in order to find the equation of the inverse, you flip-flop x and y, and you solve that new equation for y. And you use your regular algebra rules. So you would first subtract 2, and then you would divide by 3, and then you would take the 4th root. But whenever you're taking an even root, we always write plus or minus in front, and that would be the equation of the inverse. I'm going to add some extra examples to accommodate some extra problems on the final that have to do with interpreting graphs. So in this particular graph that did come out of the homework, we want to determine the intervals on which the function is increasing and on which it is decreasing. So I circle part A because that part is on the final. Part B will not give you a graph to find a max or min. You'll be using your graphing calculator to do that. So the intervals on which this is increasing and decreasing. So I want you to notice first from 0 until here, which looks like it's at about 150, it's increasing. So we say it's increasing from 0 to 150. The intervals of increasing and decreasing are always the x values, not the y values. Then, from 150 until about 300, it's decreasing. So we would say it's decreasing from 150 to 300. And then it looks like it's increasing from 300 on to 400. The reason I stopped at 400 is because in an application problem, it could go back down again, so I don't want to make that determination. The other thing we'll ask you to do with a graph like this is determine an average rate of change from the graph. So let's find the average rate of change. Average rate of change from x equals 150 to x equals 300. So at x equals 150, it looks like y is, let's see, maybe it's about, let's see, what's halfway between 175? That's about 87.5, so I'll pick that. It's probably not exactly halfway, but it's close. And then at x equals 300, the y-coordinate is just under 25. So if you want to pick 24 or 23, on the test, the problem you'll get, the outputs will be more exact. You'll be able to determine what the right answer is. So remember, average rate of change is just slope. So if you're just finding the slope, it's going to be y2 minus y1 over x2 minus x1. So it's going to be negative 64.5 over 150. And then it's about negative 0.43. Let's see. Days or weeks per day, I guess, is the unit of measurement. Not weeks per day. Feet. Feet per day. Let's try that. And it makes sense that the answer is negative because the interval that I chose, the graph is going down. Here's another extra problem. I varied it from the one that was in the textbook. So if I give you a graph of g of x, and I want you to tell me what the graph of g of x plus 1 is, you need to know what the transformation is. Well, g of x plus 1 means up 1. So I would literally take every single point on this graph and move it up 1 unit. And so there would be the graph of g of x plus 1. I'll use a different color for g of x minus 2. That would be down 2. So I would take every point on here and I would move them all down 2. And there would be the graph if I moved it down 2. If we wanted to move it left or right, if I did g of x plus 1, that would be left 1. So I would take all the points and I would move them left 1. And then if I wanted to move it to the right, same thing. We're not testing you on these because these get a little more complicated. And that is the Honors Semester 1 Review 25 to 36 plus some extra problems to accommodate everything on the final exam.